Hello, this is Pat Kelly. In this problem, we're asked to find the area of a given region. And for me, this region was x squared plus y squared equals 4. I've quickly drawn that for you, and it's a circle. And we're going to use our new knowledge, really stemming from Green's theorem. We have this formula for the area. And these are nice little problems where you know what the answer is from like grade school or something like that. But you see how you get the same answer with our new concepts. So there's no discrepancies. You know the area of this circle where the radius is 2 pi r squared. We should anticipate an answer of 4 pi. Let's get there using this new formula. So I'm going to get into this integral. Before I can even use it efficiently, I've got to get everything in terms of the same variable. Okay, so I've got x's and y's over here, and x's and y's in the curve that they've given me, but I'm going to convert to theta using our polar coordinates. Okay, so let me start with that, is knowing how to convert this circle to polar coordinates. My x is just going to equal r cosine theta. I pause there because r is constant. We have that radius of 2. So let's just jump right in and say 2 cosine of theta. And thinking just a little bit ahead, I will need a dx. So let's differentiate this equation while we're at it. I know I'm going to need a dx in the formula. So the derivative of cosine theta is minus sine theta, and you have your coefficient of 2, and then the d theta will tack on there. And let's do the same thing for y, which is going to equal 2 sine theta, and I'm going to need a dy in a minute, and that's 2 cosine theta, d theta. All right, now you've got some pieces of the puzzle to plug into your formula, so we're pretty much ready to calculate this a equals 1/2. My integral this time, well, I'll pause there. I'll put it on the back burner there. My limits of integration, of course, you want to address. I'll come back to those. Let's fill in those pieces of the puzzle. X comes from here. That's going to be 2 cosine theta times dy, which comes from here. That's also 2 cosine theta. And then d theta. Put the d theta there. And then back to the formula, there's a subtraction, so minus y, which is 2 sine theta, 2 sine theta, times dx, which is actually a minus 2 sine theta. So let's take that minus and combine it with this subtraction and make that positive. Okay, I'll do this for you in yellow if you look back at this later. So it was subtraction, but with a minus, let's make it plus. And the rest of it is sine theta, 2 sine theta, d theta. And what I kind of put on the back burner was that we do have limits of integration, of course. And if you weren't seeing it as you were writing it down, you look back at it now and see that your differential element is theta. So your limits of integration should be theta. With our polar coordinates to draw that full circle, your theta is going to start at 0 and end at 2 pi. Okay? Now let's go down a step and clean this up. And I think you should be able to do some arithmetic with me. For one, there's a d theta here and a d theta there that we would factor out and put it at the end. Okay, fine. Here's a 2 times 2, which is 4. Here's a 2 times 2, which is 4. So let's pull a 4 out in front of the whole integral. So there's a 1/2 in front multiplied by the 4, and we're just going to get 2. And then the integral from 0 to 2 pi. And if you didn't mind doing that arithmetic with me in my head or in your head, now let's do some trig in our heads. Don't worry, it's not as scary as it sounds. Look at what's happening. Cosine times cosine is cosine squared. Sine times sine is sine squared. Cosine squared plus sine squared, you know, equals 1. So this integral collapses to just d theta, 1 times d theta. Okay, cool. Now we can do this integral pretty easily. Let me stay up here for some room. d theta just integrates to theta. There is a 2 in front. The theta has to run from 0 to 2 pi. Plug in that 2 pi. Plug in the top limit, the 2 pi times 2, which is 4 pi, and subtract what happens when you plug in the 0, which is 0, and there's our answer, 4 pi that we expected. Okay? Try some more on your own. You should get the right answer. I'm sure you will.